Today's geometry notes will focus on in class 34. This is day 2 of standard 8. We're going to be talking about parallelograms again, but bringing back some algebra topics from your Algebra 1 days and talking about an idea called coordinate proof. So first and foremost, let's make sure that you remember how to plot points on coordinate grids. We did this back in standard 4 when we were working on transformations. That first ordered part of the ordered pair is the x value, the second part is the y. Remember, your x-axis is the horizontal one and your y-axis is the vertical. When x is positive, we're moving to the right. When y is positive, we're moving up. So we're going to start at that origin and move 1, 2, 3, 4, 5 to the right and 1, 2, 3 up to find the placement for point A. If we continue on from there, our goal is to graph B next. That means that we're moving 3 to the left and 1 up from the origin. So 1, 2, 3 full boxes left and 1 box up gives us that location for point B. C is going to be left but down. So 2 full boxes left and 1, 2, 3, 4 boxes down, point C. And then for D, we're going right again, but now down. 6 full boxes to the right and then 2 down. Okay, so when we plot the points, we want to make sure that we label them. And then we're also going to be taking those points and we're going to be connecting them to create our quadrilateral. The goal will be for us to determine whether that quadrilateral is actually a parallelogram or not. So we're going to create quadrilateral ABCD by connecting the points in the order they were given to us. So A connects to B connects to C connects to D, and then D connects back up with A to make that four-sided shape. Thinking back to the in class 33 notes, the definition of a parallelogram is that there are 2 pairs of opposite sides parallel. And so if we're going to show that this quadrilateral is a parallelogram, we're going to need to come up with some kind of way to demonstrate that opposite sides are parallel. Now, back in our standard 7 parallel line proofs, the only way we could prove that 2 sides of a shape were parallel was by using a converse. So we'd have to use the corresponding angles converse or the alternate interior angles converse, or there were a couple of others. But those required us to know information about angles. When we're working with a coordinate grid, there's going to be an additional way for us to show that sides are parallel. And that is by going back to an Algebra 1 concept called slope. Slope, remember, is the rise over the run. So when we're moving from one point to another, we count how far we go up and then how far we go over to the left, and then that would tell us the slope of that particular side between C and B. So if sides are going to be parallel, they are going to have the exact same or equal slope. That means that they'll be pitched at the same angle, so they'll travel in the same direction, they won't get closer together, they won't get farther apart. All right. That one fact is going to help us to get to the idea of constructing coordinate proofs. So there are 3 different steps that we're going to go through to put together a coordinate proof. This is not a 2-column proof like you're used to. So what we'll be focusing in on is using our algebra skills to help us to determine whether or not quadrilaterals that we graph or that we have points for are parallelograms or not. So step 1, we're going to plot, we're going to label, and then we're going to connect the 4 vertices of the quadrilateral. Now, in order to do that, we have to pay attention to the name or the order in which we connect those points. So this says create quadrilateral ABCD above by connecting the 4 vertices on the graph. So that's what we did. We connected A to B, and then to C, and then to D in that order. If they had named the quadrilateral something different, the letters had been in a different order, then we would connect those points in a different order and it would make a different type of shape. Step 2 is going to be to use our slope formula, or we can actually find slope by counting on the graph as well. 2 ways to find slope, to determine whether the opposite sides of that quadrilateral turn out to be parallel. So, as a reminder, your slope formula, the abbreviation for slope, is m. So in order to find that slope, we have to take y2 minus y1, and then we divide by x2 minus x1. These y and x values come from your ordered pairs. So if we're trying to find the slope of segment AB, since it's hard for me to show the top of the page on the document camera, I'm going to copy down, where would be the best place? Maybe right here. A is at 5, 3, and B is at negative 3, 1. So if I'm looking at those ordered pairs, the slope formula would look like x1 and y1 from that A ordered pair, and x2 and y2 from that B ordered pair. So if I'm following out my slope formula, I would be taking the second y value, 1, minus the first y value, 3, then the second x value, which is negative 3, minus the first x value, which is 5. If we do some simplifying, 1 minus 3 is negative 2, negative 3 minus 5 is negative 8, and then if we reduce that fraction, we can divide both of these by the common factor of negative 2, and the slope for segment AB turns out to be 1/4. Okay. The other alternative is that I can do this from my graph. So I'm trying to think. I think I'll have to slide up here so that we can see it. I'm not sure you'll be able to see. Well, there we go. I can count it and write it at the same time maybe. So if I want to find the slope of segment DC, I'm going to focus on counting that rise over the run. So if I go from D to C, the rise would actually be negative 2. It would take me to 2 boxes down to get matched up with C. So that would be the top of my fraction. And then 1, 2, 3, 4, 5, 6, 7, 8 boxes to the left would be a negative 8. And then same thing as before, that has a common factor of negative 2. So if I reduce that fraction, it's going to turn out to be 1/4. So it's really up to you whether you want to use your slope formula to find the slopes of the sides or whether you want to use the counting method to find the slopes of the sides. It is important that if you're using the formula, you're paying very close attention to positive and negative signs, especially with subtraction happening. If you subtract a negative, remember that turns into a positive. And with counting, it's very important to pay attention to when you're moving up or right, it's positive. When you're moving down or left, it's negative. Now, because these slopes turned out to be the same, we can say, yes, these sides are parallel to each other. That's not enough, though, to know this is a parallelogram because we need 2 pairs of opposite sides parallel. So we repeat that process with sides AD and BC. I'm going to go ahead and let you find those 2 slopes so that you can try it out for yourself. Meet me back here in just a minute. Go ahead and press pause, and we'll talk about what you should have ended up with. All right, welcome back. I found the slope of segment AD by counting. So I counted down 5 and then right 1. Negative 5 divided by 1 is just negative 5. But I wanted to find the slope of BC using the formula just for practice because there are a lot of negative values in this formula. So I wanted to show you what I meant about being careful with the subtraction and the negative signs. So if we use our formula, y2 comes first. That's negative 4. We're going to subtract y1, which is 1. And then for x, x2 is negative 2. We need to subtract negative 3. So subtracting negative 3 would have 2 signs stacked up here. So anytime we subtract a negative, I go ahead and change that to a positive. Subtracting a negative is adding a positive. Negative 4 minus 1 is negative 5, and negative 2 plus 3 is positive 1. So that slope is also negative 5. which means that these two opposite sides are also parallel. So now that we've taken care of finding all four slopes, we're going to make our conclusion. That step 3 conclusion part requires you to put together a sentence. So what you're looking for is whether or not both pairs of opposite sides are parallel, because if that happens, the quadrilateral is a parallelogram by its definition. And so what we write down is a sentence to communicate that conclusion. Remember, this is a proof, so we have to be specific. ABCD, that was the name of the quadrilateral, is a parallelogram, and then there's an explanation, because both pairs of opposite sides are parallel. And that's what all of your algebraic work goes through to confirm. All right, we're going to do one more example, so go ahead and flip the page and meet me back here for part 2. All right, on the back, we are trying to prove if the given quadrilateral SNO is a parallelogram. So we have 4 points that need to be plotted. We're going to go ahead and take care of that. S is at -3, +1, so we're moving left and up. N is at 2, 4, so that means we're moving right and up. O is at 5, -3, so we're moving to the right, but then down. And W is at -2, -4, so that's left and down. Remember, the name of the parallelogram or quadrilateral tells us what order to connect in, so we're connecting S to N, then to O, then to W, and then back to S. Now, this doesn't look like a parallelogram, but we still have to prove. We can't just say no because of looks. We have to show evidence. So when something like this happens, my suggestion is to pick the sides that definitely seem to be not parallel, because it will save you a little bit of time and effort. So I'm going to go with segment SN, and then the opposite side to SN would be side WO. I'm going to use the counting method to find the slope of SN. So my rise would be 1, 2, 3, up, so positive. Run would be 1, 2, 3, 4, 5 to the right, which is positive. 3 and 5 don't have anything in common, so 3/5 is already simplified. Doing the same thing for side WO, the rise is only 1, and the run is 1, 2, 3, 4, 5, 6, 7. 1 divided by 7 can't be simplified either, and those are definitely not the same. So that means no, these sides are not parallel. Now that's enough to prove that this is not a parallelogram. When it is a parallelogram, you need all 4 slopes. But if you run into a set of slopes that are not equal, that means a set of sides that are not parallel, you can jump straight to your conclusion, and you can say SNOW is not a parallelogram because both pairs of opposite sides are not parallel. All right, that's it for the notes for today. We will see you back in class. Thanks for watching.